All right, real quickly, let's talk about experiment 1 to experiment 8. These solutions deal with, these experiments deal with litmus solutions. Now, right off the bat, you do experiment 1. And experiment 1 deals with filtering. It's basically how to teach you to filter. It requires you to get some sand. Don't go and buy some sand. You don't need a handful. You just need a little bit. You can generally find it lying along the side of the road a lot of the time. Although that's dangerous. Don't go play in traffic. If you can't find any from a cheap, free source, worst case scenario, you can use some household dust. Right? You've got that one door frame you haven't dusted above, right? Wow, how many times can I say right in the space of 30 seconds? Now you guys are going to be watching it and counting it for the rest of the lesson, aren't you? At any rate, I digress. So for experiment 1, if you can't find sand, you can use some potting soil or you can use some household dust. Also on experiment 1, you have to turn in of your filter after your water's filtered out through it. So give me a picture of the filter and the water after it's passed through the filter for experiment 1, and that's what I'll be looking for you to turn in for experiment 1. Experiment 2. Oh, by the way, in both experiment 1 and experiment 2, and a couple other experiments, the instruction booklet references the filter papers that came with the kit. The kit no longer includes filter paper. You have to go and buy and cut a coffee filter. I use coffee filters a lot. I don't drink coffee, but I do so much home chemistry myself and with my kids that I have a bunch of them at home. They're really, really super cheap. I think I got 100 on sale at Kroger's for 50 cents one day with my little card there. So you can get coffee filters fairly cheap. You'll need coffee filters. You'll also need denatured alcohol. They keep saying denatured alcohol. It's what you would call rubbing alcohol at the store, or isopropyl alcohol is what they're referring to. So you're going to need some rubbing alcohol or denatured alcohol. And you're going to use both items several times during the course of this semester, so don't lose them once you buy them. Not only that, but for experiment 2, you're making a litmus solution. What is a litmus solution? Well, your greeting goes into what a litmus solution is, but a litmus solution A litmus solution is a solution that changes color depending whether it's mixed with a base or an acid. A litmus solution is blue in the presence of a base and red in the presence of an acid. And you can remember that simply because blue and base, and I'm using a red pointer for that. That's one of those things that messes with your mind. All right, here we go. It's blue in the presence of a base. blue base. Both begin with the letter B. So a litmus solution is a solution that is blue in the presence of bases and red in the presence of acids. Which brings up the very good question. What does death mean in the Star Wars universe if all the characters keep coming back blue and gluey after they're blue after they're killed? More importantly, if Yoda could use lightning to set the Jedi books on fire when he was a ghost, why couldn't he use that same lightning to go medieval on the Emperor while the Emperor was still in power? Just saying. Oh, as long as I'm saying things, why don't you write down Yoda since I went on that very random diatribe? Write down Yoda. Alright, once you've written down Yoda, let's define what an acid is and what a base is. To understand what an acid or a base is, we have to know a little something about the nature of water. Water, you probably know, has the chemical formula H2O. Meaning it consists of one oxygen atom combined with two hydrogen atoms. If I were to draw it, it would look like this. When we have a cup of water, we have gabillions and gabillions of little units of hydrogen bonded to oxygen. We have lots of little units. Why is my stylus not working for me? Come on, work for me. We have So if I have a glass of water, I have a huge community of billions and billions of these molecules. So I've got billions of molecules in my glass of water, where an oxygen is married to two hydrogens. We know that in America, we have a high divorce rate. Well, guess what? Same way for a glass of water. Although in a glass of water, most of these water molecules are happily married to each other, a small portion of them, 10 to the negative 7th, in fact, really small number, right? 10 to the negative 7th, basically 1/10,000,000th of the molecules basically one water molecule out of 10 million, although there's a little bit of fudging in my numbers, but I'm trying to keep it simple here. One water molecule in 10 million wind up doing what we're talking about and getting divorced. Well, that 1 in 10 million that gets divorced always gets divorced in a special way. Now, what makes the water molecule relationship a little bit unique is it's a three-way relationship, right? There are three parties involved in this relationship. You've got a hydrogen and oxygen and another hydrogen. Well, every so often, that 1 in 10 million, the water molecule finds that one of its hydrogen can't get along with the other oxygen and hydrogen. Matter of fact, that other hydrogen is so desperate to get out of there that it's willing to pay a high price. It's willing to leave its kids behind in order to get its freedom. It's willing to give up an electron in order to escape the water molecule and live as a hydrogen ion. So when that one hydrogen leaves, that leaves an oxygen and a hydrogen by themselves and very lonely. This oxygen-hydrogen by itself with an extra electron is referred to as a hydroxide ion. So long story short, cutting through the drama, inside a glass of water, some of the water molecules will choose to break up into the hydrogen ion and the hydroxide ion. In what's known as neutral water, you can't form a hydrogen ion without forming a hydroxide ion. So in neutral water, the concentration of your hydrogen ion is equal to the concentration of the hydroxide ion. There exist, however, substances that upset this balance. These substances are referred to as acids and bases. It turns out that not only is the concentration of hydrogen ion in neutral water, the concentration of hydrogen ion and the concentration of hydroxide ion are equal. An acid is any substance that increases the hydrogen ion concentration. But wait, that's not all an acid does. Remember, we said that these hydrogen ions were formed when a water molecule broke up into a hydrogen ion and a hydroxide ion. Well, this hydrogen ion broke up, and they're now free to date whoever they want. Well, these hydroxide ions over here, they're free to date whoever they want too. And if an acid comes along and increases the concentration of hydrogen ions, well, there's a whole lot of hydrogen ions for these hydroxide ions to date. So that means the hydroxide ion is going to get to go out on a lot of dates. You go out on enough dates, and eventually you find true love. Meaning that the hydroxide ions will react with some of these increased hydrogen ions and reform water. If you don't understand the gobbledygook there, what I'm saying is that acids not only increase the hydrogen ion concentration, but they decrease the hydroxide ion concentration as well. Acids increase the hydrogen ion concentration and decrease the hydroxide concentration. So acids increase the hydrogen ion, decrease the hydroxide ion concentration, which means that for an acid, the hydrogen ion concentration is going to be greater than the hydroxide ion concentration. Well, let's see. Why don't you write down Perry, Agent P. Write down Perry for me. I am all over the place today. I'm sorry I'm not theming my words today. I'm just randomly looking around my office, and I've got a Yoda notebook, and I've got a Perry the Platypus action figure. So, write down Perry. For bases, the exact opposite is true. Ooh, I used the wrong 4 there. For bases, the exact opposite is true. bases increase the hydroxide ion concentration and decrease the hydrogen ion concentration. So if you have a base, you're increasing hydroxide and you're decreasing the hydrogen ion concentration. And that's what an acid and base is. This excess of either hydroxide or the excess of hydrogen is kind of like Sith and Jedi. We know from Star Wars myths that if the Jedi ever become too powerful, the dark side increases in power to counterbalance them. If the Sith ever become too powerful, the light increases. Right? Anakin brought balance to the Force by increasing the power of the Sith. Rey brings balance to the Force by being the light side that rises to meet Kylo Ren. We see the same things happening with acids and bases. The reason acids cause damage to your skin, damage to your eyes, damage to your body is they're reacting with the chemicals in your body in an attempt to restore the balance of hydrogen and hydroxide. The opposite's true for bases, right? Bases are reacting with your body, and they're reacting in an attempt to restore that balance of hydrogen and hydroxide. So it's that quest to seek balance that causes the acids and bases to cause damage to different things. All right, but I got way off track. Let's get back to the experimental run here. So in experiment 2, your solution that tests for acids and bases based on color change. It should be noted in experiment 2 that you have to let your solution stand for 24 hours. Always let your solutions, always store your solution safely away from children. For experiment 2, you're going to turn in a picture of your filter so that I can see that you filtered your litmus solution. All right. Experiments 3 through 5, you're having some real fun with some color changes. I'll actually do these series of experiments when I'm entertaining people because they're so really, really cool to look at. Couple notes here. For experiments 3 and 4, you're going to be using sodium carbonate and citric acid. Notice that for sodium carbonate, and citric acid, note for the citric acid and sodium hydroxide that you're going to be using, there is safety information that you need to be aware of on page 7 and 8. You need to wear goggles. You should be wearing goggles even when you're doing experiment 1, where you're just filtering sand. But be especially aware of that when you begin using your chemicals, sodium carbonate, citric acid, and remember to open carefully. 2, well, let's just say this. After each experiment, for experiment 3 through After each experiment, for experiments 3 through 7, take a picture of the test tube. That means I should have 5 pictures in total. Make sure you keep those pictures straight because I'm going to have a separate drop box on Blackboard for each one of those experimental steps. Experiment 8 real quickly. Experiment 8 calls for mineral water. Mineral water is also known as carbonated water or soda water. That really nasty bitter stuff. If you don't have mineral water or soda water, you can go out and buy it. It's not expensive. That having been said, if you're trying to avoid a trip to the grocery store and you have a Sprite or Sierra Mist around or 7-Up, those will work as well. Either way, you shouldn't drink anything in the lab. And remember, do not eat or drink anything while experimenting or that was used in an experiment. Let's see. Once again, after experiment 8, you're going to turn in a pick. And the last thing to write down to conclude today's pre-lab lecture, why don't you write down Eddie George? Why? Because I have an Eddie George action figure from Todd McFarlane sitting right next to the Perry the Platypus action figure on top of my computer. Alright, so we covered Star Wars, Phineas and Ferb, and the Tennessee Titans today. That's it. Beep.